Today we are completely going to see what is analog sensors and how to code that particular analog sensors, and from that analog sensors how to differentiate that particular analog values as well as the digital values. So this kind of interfaces only here we will be completely seeing. And for our functions, here we have gas sensor as well as LDR. So both these particular sensors will be integrating with LED. So from that particular LED we will be able to get the indication as an output. So once when we go for this kind of sessions, the first session will be for interfacing with LDR, and the second one it is for interfacing the gas sensor. So first let us start with LDR. LDR, it is commonly said as light dependent resistor. So within this particular light dependent resistors, we will be having the required knowledge on this particular ADC. So inside each and every Arduino, we have a particular port known as analog in, so which comes under the ADC part, which is also known as analog ports. So commonly the ADC is known as analog to digital converter. So whenever we are integrating this kind of digital conversions or applications, here we have to know what is the purpose. So generally the analog waves are commonly said as the physical one. Whatever the analog waves which we are going to see inside our particular controller, it will be varying from 0 to 1023. So this will be the particular analog values which we will be able to see inside a controller. How this we are able to get it? So initially we will be having this controller as a mediator section. So instead of going for controller, we can directly make it as ADC itself, analog to digital converter. Now inside this we have to send the analog data. So generally this analog data completely will be in a wave form. So this is completely the physical value, like this can be set as the 0 and this can be set as the particular peak value, and again it comes to 0 then peak value. So in this particular way only each and every analog values are being upgraded. Now from this we are just providing directly towards this analog to digital converter or ADC, and from that we are obtaining the data in the form of 0 to 1023. Directly if we go for the digital data or any of the digital sensors, so like here we are directly connecting the digital sensor that will be integrated towards the microcontroller. Microcontroller already it is a digital platform which reads in the form of zeros and ones. So from that we will be getting this output, 0 as low, 1 as high. So from this only we will be just converting the entire data into the respective parameters. That is like we can go for temperature, speed. So these kind of sensors and all, we will be able to measure this kind of data after converting into zeros and ones. But inside the ADC it will be straightly going towards this 0 to 1023. So this can also be set as that particular analog values once whenever it gets converted. And from this particular values whatever we are able to receive, we will be able to convert it based on our requirement. Here also the same, temperature, speed and all other analog sensors. But while compared to the digital as well as the analog part, analog only mostly providing in the form of a good or a required kind of data. So from that particular data, here we will be integrating the different parts, and from that parts here we will be able to work with many kinds of interfaces. So inside that particular section, once when we are going to program it, we can separate it as easy as possible, where the analog write comes under the pulse width modulation, analog read comes under the reading of the data from analog sensor. So in this way only we can differentiate analog as well as digital sensor. So in this way now we will be connecting our entire circuits and this particular LDR, here it will be interfacing this light. Based on the light, the complete resistance will be changed. So here this particular light is considered as analog input. From that particular analog input, therefore we will be using our ADC, which converts the resistance value from analog to digital, and therefore we will be able to get an 8-bit output. And from this, the variation will be from 0 to 1023. From that we will be able to make an application like automatic street light, and at the same time, based on the intensity, the brightness of the light control. So from this particular applications only, we can also come into the real-time application like automatic street light based on natural light intensity. So that is a highly used embedded application with the help of LDR, and this also has been implemented in many places. Now the circuit for LDR, hereby we have that particular LDR with a pull-up resistor, so it has been connected to the positive section. So that particular section will be integrated towards analog A0. Then the same section only here also it will be indicating as power supply. The center pin, it is for ground. So here we will be using only 2 pins. Now let us program for this particular sensor. So here we have void setup and void loop. Now therefore pin mode within bracket A0. So here we are going to take it as input. Maximum all the analog sensors will be taken as input only. The sensor meaning itself, it is considered as input. The analog port is also we are using for input, other than 2 ports like A4 and A5, which comes under SEL STA for I2C purpose. Serial.begin to enable the serial communication to see the values. The baud rate is 9600. Now hereby I am collecting the data int A equal to analog read within bracket A0. First let us see what are those values. Serial.println A. Then after seeing that particular values, we can make it up. So hereby I am taking those required parts. Now from this I have connected to A0. Now I am going to upload the code by plugging up the entire data. So it is COM8 and Arduino Uno. First we have to save it. Therefore the code has been uploaded. Now let us open the serial monitor. So hereby it is indicating as 0. Now let us cover it. Now we are able to get some value, and the values are quite little bit speed. So let us provide a delay. Uploading is done. Now hereby I have not covered anything and it is completely getting that values. Now I am just going to cover. Whenever it is getting covered, there are some changes. Now it might be complete dark inside my hand. Even though if I leave a small gap, then also the complete thing is getting changed. Now the resistance values is keeping on increasing up over there. So in this way only the values will be changed up. Now let us write a condition for this. If A greater than, make it as 50, digital write within bracket 4 comma high. So whenever it is little bit dark, during that particular time the light will be enabled. Similarly, if the condition is not there, we are providing it as else, digital write 4 comma low. Now let us upload this code, and before uploading we have to enable here also in mode 4 comma high, output. Now hereby I am taking one of the LED, giving the required connections in ground and another one in 4. Now it is uploaded. I have given it as A greater than 50. So hereby it is glowing when it came less than 50. Now since it is greater than 50, only for fraction of seconds it is there. Now it keeps on glowing. So this section can be taken as automatic street light. And without microcontroller also creating of automatic street light is possible. You have to use BC547 transistor for that particular circuit. So with that also we can create the same project without the controller. This project is with controller. Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel.